Uh, Good morning, everyone, and thank you for coming to the session. And there has been a break of almost 1.5 years since we last around one plus month, sorry, uh, since we had our last session on mini hydro projects. Today, I will go through some exercises and case studies related to social and environmental safeguards and basically economic. I mentioned economic and financial assessment, but basically we're looking at mostly financial assessment right now. The second part will be a follow-up to what Mr. Bart has already covered. So I will not go into the detail of the financial modeling and different aspects, but I will just try to add some information that will be needed to do the financial modeling of mini hydro project. Okay, to start with, let me, as I mentioned, the first part will be on the social and environmental safeguards. And uh, I will basically, I actually covered this, the technical part of the social and environmental safeguards during my lecture on Hydro04 on social and environmental safeguards. So basically, the principles of environmental and social safeguards were already covered under Hydro04 lecture. Today, I will quickly review those that lecture session, then go to some practical case studies, exercises on how social environmental assessment is done. Okay. Uh, just to review what we did, we discussed under lecture the Hydro04 about a month or two ago. There are key stages of the environmental assessment. Of course, the first important thing is the screening, and it is usually using checklists. And I will provide a sample of a checklist that can be used for mini hydro projects. Then, of course, one important part is an option assessment. Any environmental, social, especially environmental assessment, has to deal with options. And one of the option is also not to build the project. What will happen if you don't build the project? There are other, you start with preliminary assessment, scoping, and according to the requirement, you do the EIA. And of course, monitoring, auditing is also very important. I will not go into the specifics of this because this was covered earlier. And the whole EIA process, this is listed. This was already covered in lecture 4. But one thing I would like to stress here is the public consultation is a key component of each step of the EIA process, okay? For project screening to identification of impacts to preparing the environmental information sheet and other things, scoping. And then finally you do a decision making, as I mentioned, post audit is also important. So this was covered. So in the case of Mozambique, based on the review I had done, and this was also covered in Hydro04, this is the ministerial decree, and there are 4 categories of projects: A+, A, B, and C. And of course, A+ category has major impacts and a full EIA is needed. A has, yes, it has significant impact, but not as significant as in A+. And B or C do not have significant impacts. I would think that mainly mini hydros, micro hydros will either fall in B or C. So this will actually not require a full, uh, this will not require a full EIA, but basically either a simplified environmental assessment or environmental management procedure. Okay, it's like how do you manage the environment? Just a procedure guideline, a so-called environmental management plan. And according to the EPDA, the Environmental Pre-Viability and Definition Scope of Study, the key components are, of course, the biophysical and the socioeconomic information, which includes land use in the area, what are the activities going on, and how the activities are implemented. So this was also covered earlier. And there is the TOR has to be prepared, and this is also covered. I will not go into this. What I would like to now just add to it is we have to first identify the potential environmental and social risks and impacts. Okay, now let me just try to see how, I will try to, I want to show, do a small survey. Let me, okay, I want to actually do a polling of, okay, I want to basically ask you I request you to give your answers to basically two questions. Okay, can you do you see the question? Two questions I have given in the poll questions. One is, do you have any prior, let me put it here so it might be easy for you to see. Do you have any prior experience in social and environmental impact assessment of any projects? Your answers, you can give either yes or no. That is the first question. And based on your opinion, what do you think is the main barrier for hydropower development? Is it financial viability of hydropower projects? Is it limited suitable sites available? Or is it the environmental and social impacts? So let me give you just 1 or 2 minutes. Yeah. Okay, please do not hesitate to vote. There is no right and wrong answer. I just want to basically get an idea of your experience in these two fields, and what do you think about these issues. Till now, we have out of 16 participants, I just see 8 of you have voted. So I will just wait for 1 more minute, and I would request you to just give your views. Carlos, do you want to explain this in Portuguese?
I don't think so. I think okay. They follow it.
Okay, that's good.
Experiences.
Yeah, we have now 9 out of 16. We have given their views, and I'm getting some interesting feedback. Okay, so let me just take a few minutes more. Okay, I will now. It's about 3 minutes gone, so I just end the poll. Okay, and I will share the results. Okay. Okay, you can see that uh, out of 9 persons who voted, 4 of you have some experience in social and environmental impact assessment of any project. So that's nice. Thank you so much. And 5 of you do not have prior experience. That is good. So, so I would request you that uh, when I make my presentations, please stop me if you have any questions or any suggestions based on your experience. And regarding the main barrier for hydropower development, 44% said financial viability is the main barrier. Uh, and 22%, 2 of you said out of 9, uh, said that we have limited suitable sites, and 3 of you said that environmental and social impacts of hydropower projects are the main barriers. I think these are, I think all 3, I mean, your answers have their own rationale, justifications, and you're right. Sometimes the hydropower projects are very site specific unless you have a good site. Sometimes, and unless you have a good return tariff, sometimes the financial viability can be a problem. So you have, the design is very important. And also, I think Mozambique has, you still have a good potential uh, for hydropower, but because of other uh, land use and other development requirements, then you maybe suitable sites may be limited also, because there will be, and this is related to environmental and social impacts. I mean, so this is important. And of course, the environmental social impact can be an issue for hydropower development. Hydropower development. Thank you. I think this was a good idea and feedback from you. Okay, I will stop the sharing of this results. Then I will now go back to the presentation. Okay. Now, I don't know if you are seeing my just a moment. Let me. Okay. Okay. So basically, let me just. Okay. Okay. Basically, as I mentioned, the potential environmental and social risks and impacts, uh, it needs to be identified during the project preparation, during the feasibility study, so that you can also design your projects to minimize the social and environmental risks and impacts. Okay, and there are basically 3 phases of the project cycle where the social and environmental impacts vary. Okay, the first one is, of course, the pre-construction phase. And before you start constructing the project, uh, when you are doing the design and the feasibility study, you need to have in hand this type of information, which needs to be shared to the stakeholders. For example, what is the beneficiary population living in the impact zone? Okay, how many of you will be affected and how many of you will also benefit? But you may be a beneficiary, but because you may live further from the mini hydro project, so you do not have a direct impact, but you are a beneficiary person, okay, household. And you also need to be clear on what is the land required, because hydropower projects, of course, especially large hydropower projects, have large requirements. Uh, the mini and micro will require limited land, but still, if the any of the structures, okay, because especially, okay, the intake is in the river, but, or sorry, the weir is in the river, but the intake and the conveyance, the canal or the pipe can pass through your land. Similarly, the powerhouse can be in somebody's private property. So we need to know what is the land required and who are the landowners who will lose their land. And we have to compensate. Normally, we have to compensate for this land. Also, one very important part of environmental social risk impact is all people are not impacted in the same way. Okay, a poor or a vulnerable group or a family household are more severely impacted than a person who is not vulnerable and who is relatively well off. So our environmental social impact risk, we have to identify the impacts on the poor and the vulnerable groups. Because if a poor person or a vulnerable group, and by vulnerable group, there are different definitions, okay? Some of them may be ethnic groups from ethnic indigenous communities who depend on the natural resources of that particular area. And if you displace them, it will be very difficult for them to adapt or cope with the impact. So similarly, a widow or a person, elderly person, a person who is old, if you displace that person, then he or she will have will have difficulty in recovering from the impact. Similarly, if you are poor, the impacts will be more for the same impact. Okay, and finally, uh, because especially micro mini hydro projects, in large hydro this is not so much, but in mini micro hydro you may be able to request people to give part of their land in a voluntary way or as a donation. So this information needs to be collected during the pre-construction phase, okay, and then and has to be shared with the communities. Similarly, uh, during the construction phase, we have a different type of risk and impact, which I will show in the next slide. And similarly, in the case of operation phase, we have a different type of impacts and risks. Uh, in the case of during construction, there are two types of impacts. One, we call it the biophysical impact on the biophysical environment. The other is the impact and risk on the socioeconomic and cultural environment. By biophysical environment, we basically mean these are the items which are affected. For example, the landscape could be disturbed. For example, there might be land degradation and land stability is disturbed because there might be when you have a canal or a pipe or a structure in an area, you could also have problems with landslide and other types of, it's not social erosion, it should be soil erosion. Sorry for the spelling mistake. Similarly, the land use pattern will change because the structures may be sited in an agricultural area or some public land, so the land use changes. Similarly, during the construction phase, you could have air pollution, noise pollution, water quality pollution, and also solid waste and muck disposal is an issue because the construction camps may generate waste, and other muck is the construction site may excavate soil which has to be disposed. So construction materials has to be handled properly. Visual impact, sometimes bird mortality, sometimes for hydro, this is not so much of a problem, but for wind or solar, sometimes it can disturb the migration pattern, the flying route of the birds and other creatures. Similarly, forest and vegetation, hunting and poaching, these are other impacts that could happen when you have construction. Okay? And this depends on various factors, but we have to be aware of these factors. Similarly, on the socioeconomic and cultural environment, there could be change in demographic profile. Okay, normally when you have, especially for large hydro, the workers there will be a small in the construction site. It will create a small what do you say, a business environment, a construction site. So there'll be workers coming from outside, there'll be entrepreneurs, there'll be people who want to sell goods. There may be tea shops, restaurants open in the construction site for the construction workers. So this will create issues on the demographic. It may change the local community. There may be more outsiders in the village than the local people. So this may create socioeconomic and cultural impacts. Okay. Similarly, when you have many people coming from outside, there could be community and occupation, health and safety issues. And especially during the COVID period, if you have a construction site where a lot of people are visiting from outside, it can create occupational health and safety issues. Similarly, health and sanitation issues will be important because you need, when you have more people in a small environment, the sanitation facilities may be stressed. So the sites, the construction sites should be well maintained. As I mentioned earlier, labor influx management, when you have people from outside coming, and so you will have, it can affect the culture, the economy of the region. Also, you have to be careful with gender and vulnerable group. Sometimes there are exploitation in the basis of gender and other criteria. Okay, some vulnerable groups who do not have the capacity to speak for them, they may be exploited. Employment opportunities, sorry about the spelling mistake here. So this will create employment opportunities, but you may need to prioritize employment to the local communities. So these are the social and environmental issues, risks, impacts that will occur in the construction phase. Similarly, in the operation phase, okay, once the project is completed, okay, but there will be major two types of impacts, okay, because of the project, a mini hydro project. I mean, you could have some, because you have the machines there, okay, you have the turbines, the generators, so they'll oil, and there's other uh, chemicals sometimes are used to uh, to maintain these equipment. So some of these wastes, sometimes unless it is disposed properly, it can create a hazard. Okay, so you have to be careful. Similarly, as you know, hydropower projects disturb, change the hydrology, because you will divert water from the river to the powerhouse. So sometimes in the river you may not have enough water, which will disturb the aquatic life. So fish, for example, habitat may be disturbed, or the fish migration path, because of the barrier of the weir, uh, may have problems. So this is during the operation, you may have impacts on the aquatic life. In terms of socioeconomic and cultural impact, as I mentioned, during the operation phase also, you have to be careful with the health and safety and of the workers and the community. So these are two major biophysical environment, socioeconomic and cultural environment issues that are uh, that needs to be considered when you plan when you do a socioeconomic impact assessment of a hydropower project. Okay, and to do that, we basically create what we call the environmental management plan. Okay, and just give me just while I do that, I just want to. I think I will do. There's another poll questions uh, I had uh, prepared. So let me just give you some uh, 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 questions on another question on what do you think? What do you think are common major social impact of any hydropower project? Okay, can you see the the question, the poll question? The answers are it could be land acquisition. Is it land acquisition? Is it displacement of people? Is it the impact from workers coming from outside? Is it health and safety of communities, or is it something else? So uh, can you like what do you think is the major social impact? Can you? I'll just give you 1 or 2 minutes. Yeah, yeah. I mean, as I mentioned, there is no right and wrong answer. So please feel free to give your feedback. Okay, we have 7 of you. We have given your answers. I will just, it's about 2 minutes. I'll just end the poll and I will, okay, I will share the results with you. Uh, like you have three of you have out of seven, three of you have said health and safety of communities is the major impact, which is correct. And two of you have said land acquisition, and two of you have said displacement of people. So I think you are, and these are, I mean, all correct answers. And so it will depend on, some projects have one type of impact more, and some have other impacts more. Okay, and there's one more, I think I have, Paul, that I had planned. Let me just look at it. Question 2. Okay, let me launch. In terms of, I talked about the social impacts earlier. Now, in terms of the environmental impact of hydropower projects, I mean, of course, basically, when you talk about environmental, it's basically biophysical impacts. Like, if you were to narrow down, what do you think uh, is the major? Is it changes in river flows? Is it impact on aquatic life? Is it land degradation? So I would like to hear from you. Or is it something else you think that I did not list it here? Okay, let me just give you 1 or 2 more minutes for this. Okay, I think we have 2 minutes done. So I will just, like, 10 out of 15 have. So I think it's okay. So I just stop the poll and I share the results. Like, out of 10 of you who responded, 7 of you have said impacts on aquatic life, and which is very, it's a genuine impact. And also changes in river flows is also correct. And of course, land degradation can also be a problem for hydropower projects. So thank you. I think I mean, all of you, I'm happy to note that you have some experience, and the answers, the feedback you have given are very relevant. Thank you so much. Okay. So let me continue. Regarding the environmental management, okay, you identify the impacts, and you do the risks. Then based on that, you are, especially for a mini hydro project, as I mentioned, you may not need a full EIA, but you would need an environment management plan. And so this plan will look something like this. Okay, just give you an example. You basically have 6 columns. So you first identify the impact and the issues in the first column, and different phases in the pre-construction phases, the construction phase, then of course in the operation phase also. Then, okay, so in the bidding process, okay, you, as I mentioned, you identify the major likely impacts. Then you also prepare this environmental management plan, So as a mitigation, to minimize these impacts, okay, you will include the EMP measures in the contractual document of the project. So you have a contract for construction. So you put the contractor during construction or later has to make sure that they follow certain environmental mitigation measures listed in this such an environmental management plan. Okay, and the guideline will be provided in the environmental and social impact assessment report based on that, or an EIA. When do you do that? You do it during the bidding process. When you bid, when you select the contractors, who is responsible, the owner of the project is responsible, and who does the monitoring. It could be a project management unit, or also sometimes for large projects, you have the national regulator who is also responsible. Similarly, for example, during the construction phase, you have land use changes. So what do? What are the mitigation measures? You have to list down the mitigation measures so that this has to be followed. Okay, you try to make minimum. So when you do the construction, you try to limit the area of impact to a minimum area where the structure is situated. You don't want to use the whole land. And if there is any slope disturbance or a soil loss or something, you try to plant vegetation to make sure that you bring back to the original condition. So these conditions are actually our mitigation measures, has to be followed by the contractor and has to be monitored by an agency like the project management thing. So when you have soil loss for noise and other aspects, you have to basically prepare this mitigation plan, okay? And this is just an example. I just gave you a format, but I will show you basically three, references, okay? And this is based on the environmental and social management framework of an agency called Alternate Energy Promotion Center, basically that promotes renewable energy technology in Nepal. And they have listed certain potential risks. They also have, today in the documents that were shared to you before the class, I have the framework I have shared, and these are the small the parts of that document which I will just go walk you through so that you have an idea of these documents. Let me just go back. Okay. Okay. So this is the first document. I don't know, maybe you cannot see here. I will just bring it here. Now you can see. Okay. Can you see the document called Annex 3? The document is identification of potential environmental and social risks and impacts. Carlos, can you see this document?
Yes, we can see it.
Yeah, thank you. Okay, so this document basically lists, just an example I wanted to share with you. It basically lists the potential environmental and social risks. So, okay, as I mentioned, during the pre-construction phase, during the construction phase, you have, if there is a landscape disturbance, okay, during the construction phase, what are the mitigation measures, possible mitigation measures? Okay, like minimal disturbance to the slopes, implementation of appropriate slope and slope protection structures, construction of adequate and appropriate drainage systems, revegetation of the disturbed slopes, and application of proper bioengineering measures. So these gives you, this is the mitigation measure for landscape disturbance, for land degradation, what could be the mitigation measures, for land changes in land use, for air pollution, okay? You basically, the mitigation measures means when there is lot of movement of vehicles, and if the road are not paved, okay, if it is dirt road, especially in the village, in the communities, these are dirt roads, it can create problems of air pollution to the communities living in the adjacent land. So basically, the contractors are required to spray the road surface regularly. So these are some of the things. In the terms of noise level, what do you do? Okay, you cannot, I mean, just because you are constructing something, you cannot use equipment and construction material that creates a lot of noise, especially at night time. You don't want to disturb the community's living, so you have to be careful. So similarly, on water quality, you have certain you don't directly discharge the waste into the rivers, so that you don't any oil spill, you cannot discharge in the river. These are the mitigation measures. On solid waste, these are the mitigation measures. So there are various issues and impacts, and the mitigation measures are listed here. So this gives you a very good, this document, which I have shared in the folder that was shared with you, gives you the key impacts on social and environmental impacts. So, I mean, I would request you to have a look at those, so that it will help you when you are designing or managing a project. Okay. Similarly, I will share basically a checklist. Okay. This checklist is similar checklist for environmental social screening for a micro mini hydro mini grids. So basically, you have in the checklist, you have the project background. Then in the project selection criteria, okay, you try to make sure, okay, over here, since this is a document of the agency in Nepal called AEPC, in several places AEPC is given, but this is applicable to any uh, uh, mini hydro or renewable energy development uh, development project. So these are like, is the project sited in ecologically sensitive areas? I mean, if it's sometimes, you know, you have protected forests, protected areas on a wetland. So you want to make sure your projects do not disturb these habitats. Okay. Does it involve a large scale resettlement? Okay. If you have to resettle many people, okay, and every country has their rules. In Mozambique also, I think your resettlement regulation will, the land policy will dictate what are the compensation or rehabilitation packages you have to, resettlement packages you have to give. Okay, so these are, I would like you, I would request you to go over it, and you can ask me questions today, or you can in the next class you can ask me. And similarly, environmental and social screening, is it as I mentioned, is it near natural habitats, is it near a religious place, or is it near any important cultural locations? These are very important things that needs to be uh, screened early on, because you can design during feasibility. These are all required during the feasibility study of your project. Then you can design your project to have minimum impacts based on these conditions. No, for example, labor and working conditions. No, I mean, you have to make sure that you follow the government, states, labor laws. Make sure that nobody is discriminated. You may need to put a clause saying that priority should be given to local communities for employment. This will help you make the project more community friendly. Similarly, I'm just going a little bit fast here. What are the potential impact? As I mentioned, land acquisition, what type of land required. So these should be all, and how do you want to procure the land? Will it be voluntary donation or involuntary acquisition? Involuntary acquisition means that you have to uh, convince the people to vacate their land, and you have to compensate them for their loss of property. Okay, and you have what you known as a resettlement and land acquisition plan, which is prepared. So these are the checklists that needs to be followed, and I will request you to have a look at this checklist, and if you have any questions now or later, please let me know. So this is the second thing that I wanted to share. And finally, I wanted to actually just a sample, I wanted to share a sample environmental management plan. Okay, and this sample is given here. It's also from that document I mentioned, and it basically, as I in the PowerPoint, I already did this. I showed you in the slide earlier. This one I had shown you the environment management plan example, and this one is basically let me okay. So this is the full mini hydro example. Okay, for soil loss, what are the mitigation? So ignore because this responsible agency and the monitoring agency will be different in your case. Okay, ignore it, but you have to do it from your related agency. But as an example, so regarding noise, so you don't want to use heavy equipment with the national regulation. You don't want to use it at night. You provide personal protective equipment. You provide if the workers need to work in very noisy places, then they should be given with air muffs and air plugs. Similarly, for air quality, you have to do water spraying. For forest and vegetation, you have to make sure the workers do not sort of poach, do not take the wildlife or do not disturb the habitat of this wildlife. Regarding employment, you may require the contractor to use local human resources to the extent possible only, and provide skills development training. So these are all part of the environmental social mitigation plan. And for health and safety, you have to have strict implementation and other things. So these are very good examples. And during operation phase, how do you manage the waste generation? So there has to be a lot of community dissemination, and the community have to be sensitized to do that. And for the local employment, you basically sometimes the local communities may not have the skills necessary to run the project, but with proper training, they can do that. So training should be part of the social and environmental impact management plan. For safety, you have to give them proper protective equipment, personal protective PPEs, and they should be, the construction areas should be well managed. So these are, I think, very standard but very useful environmental management plan documents that you can follow. Okay. So based on that, I would like to, because it's about 1 hour or 50 minutes or 55 minutes has gone, I would now like to ask you, I may have gone a little fast, but please, you could have stopped me. Please stop me if I go fast. But I would just like to open the floor for any questions, because this is the first part of my lecture today on social and environmental impact assessment of mini hydro projects. Do you have any questions or comments?
Good morning. About the risk assessment, in what stage it is done, the risk assessment?
Sorry, say that again.
Ask you about the risk assessment. In what stage we are doing the risk assessment?
Yes. Actually, you see, this is the, this is the whole EIA process, okay? So as I mentioned, for a mini hydro project, you don't really need the full EIA process, okay? For, let's say, in the case of Mozambique, you have for category A plus and A, you have the environmental impact assessment, okay? But for B and C, which are mini hydro projects, you have basically a simplified environmental assessment, okay? And for C, just have a good environmental management procedure to be prepared. But so, but this process is useful to understand. So if you see that, basically you have, okay, the project screening is you do when you do the checklist, the screening project, whether like this is general, this is actually the document I showed you, the second document, the screening document I showed you. So this does the scoping and the screening. But in this, after you do the screening, then you have to do the prediction of the impact. So the environmental and social risk assessment is done in almost in the beginning. First, you do just the project screening to see if it is category A plus, A, B, or C, and what are the type of impact scoping, okay? What are the issues and impacts that needs to be considered? So once you do that, then you basically identify the impacts and the prediction. So this risk assessment is done in the very beginning. Once the project, during the, as I mentioned, during the feasibility study, when you are doing the design of the project, when you have the basic layout of the project, you do this.
Thank you.
And the environmental regulation, actually, I did not show here. It was, I in fact downloaded some, I think like there is this in the reference of this, of the reference document, I have given you the, let me just go to the reference document. Okay, let me just show you one thing. Anyway, at the end of this, in the lecture, I have given you a reference link of the environmental regulation for Mozambique, you know, and in there you have the regulation, and the regulation will be quite clear on which step. But from my experience, it is done in the beginning. Once you do the project screening and the scoping exercise, then you have to do the impact assessment. And based on that, you prepare the environmental management plan, the EIA report or EIS report, all the documents are prepared based on this risk assessment. Yeah, any more questions? Yeah, Carlos, if there are no questions, should we break for about 10 minutes?
Yes, Divas, I think we can break for 10 minutes.
Okay, thank you. I will break for 10 minutes.
Okay.
And please, let's be back by, now it's 10:02, so let's be back by 10:10, okay, 10 past 10. And I will also pause the recording for a few minutes. Thank you.
Good, thank you.
Okay, so the second part of my presentation today is on on the economic and financial assessment. Basically, although I called it economic, I have to be, I must admit that it's more on financial assessment. And it is basically, as I mentioned earlier, it is basically a supplementary material to what Mr. Bhatt has already presented to you on the financial feasibility study and the modeling. And he has actually the financial analysis he has already covered in I think in the last sessions that he has covered. What I want to present today is mainly focusing on mini hydro projects, because there are certain issues I think we have to be aware when you're doing a financial analysis modeling. Okay. Initially, I will just review some materials that I presented in lecture 4, part B. And because as Bart must have has told you, the financial analysis has two parts. One is the cost part, and the other is the benefit part, the revenue, the cash flow. Okay, I mean, so your cost is the cost of the project, the capital cost, the operation maintenance cost, and other recurrent costs. And the benefit is basically for a mini hydro project or solar and bioenergy tool is the revenue you generate from the energy that you produce. In the case of mini hydro, I mean, this can be applicable to other technology too, but I will basically focus on mini hydro. We have to first, when you are planning a mini hydro or a micro hydro project in a isolated project or a grid connected project or a mini grid project, we have to basically calculate, I mean, design the project to find the optimal capacity. Okay, so the installed capacity is a design parameter. As I mentioned in my previous lecture, that according to the hydrology of the river where you are generating this hydroelectricity, the flow will vary from the minimum to a maximum. In the wet season, you have more flow, river flow. In the dry season, you have less flow. But you have to find a design capacity which will give you the energy generation that can match with the load. Okay, because the load pattern will change in 24 hours. Okay, in the morning you have more load, in the evening you have more load, depending on the type of users. If you have a commercial or a small scale industry, maybe the load is more or less the same the whole day, but still you have these the load and the benefit calculation has to be done based on the energy utilization. Okay, your whatever you generate does not mean it is utilized. Okay, it is used by the users. So you have to match the load, the demand with the supply. So this load and benefit, which I covered in 4, is an important part of financial analysis of a mini or micro hydro project. Okay, like for example, when you are going to a new area where providing electricity to a new community, you do not know the load, the demand first. I mean, you know, you can guess, but the capacity, because demand, as Bart has mentioned, it depends on the willingness to pay. Okay, it depends on the tariff. Okay, these are policies that are important because uh, like not all communities, not all households have the capacity to consume any amount of energy. It will depend on the price, the tariff, the load will depend on that. Okay, and it will depend on what type of uses they are going to do. For example, in the case of micro hydro in Nepal, uh, you do a rough estimate that for a new area, just for lighting or something, 4 or 5 bulbs, you have 120 watts per household, okay, in capacity. And you say, okay, the productive use is around 10%, okay? That means it's mainly used for lighting in a rural setting. And also you try to do in like mini hydro, micro hydro project is part of a water use development. Okay, you have other uses of water including environmental uses. Okay, so these are, you initially try to get the capacity, optimize the capacity, you try to estimate the load, and then based on the tariff that you design, you get the benefit is calculated. So it is very important to put in that model that Bart introduced to you. You have to have a benefit stream. So this part is a very important part of a feasibility study. Okay, as I mentioned, in a rural isolated system, okay, the load is typically dominated by domestic use. Okay, you don't have industry or commercial uses. It's basically domestic uses. And but what happens is after some years, 2 or 3 years, when you have access to electricity energy, the demand can increase. So somebody might open a small cottage industry. Somebody might open a small shop, a cold storage. Somebody might open a small workshop, a motorcycle workshop or some repair workshop that consumes electricity. Okay. So normally after 3 years, the demand is supposed to rise. Okay. And again, what you have is if you divide the day in 24 hours, okay, this blue line is the installed capacity. Let's say you have around, this is in kilowatt, the installed capacity of this particular example project is around 100 kilowatt. Okay, now you see that in the morning hours, you have domestic uses, okay, for small lighting and cooking. Here in the evening, you have domestic uses. And then you have during daytime, you have agro processing, you have a bakery shop that operates from 8 to something for a few hours. Then you have a herbs processing. So these are different types of load. Now you can see that in the morning, your installed capacity is less than the demand. Okay, but during the daytime, like early morning to daytime, your installed capacity is more than the demand. So now when you do a financial modeling analysis, just because you generate, let's say 100 kilowatt throughout the day, your utilization factor is not 100%. So basically the benefit is, basically this is the benefit that, because people will pay for when you use that electricity. So we have to be careful that the load and the supply may not match. And sometimes the benefit may not be for the full energy that you have generated. So this is a very tricky balancing act. We have to do that. And this one also I covered in the load. So, but I wanted to just bring it out here. And finally, this was the benefit. Finally, we need the cost. Okay, for the financial analysis, we need the cost. And And the cost is basically for mini hydro project or micro hydro project, they use 15 years of economic lifespan. Okay, so actually, I mean, okay, large hydros have more years, but they want to make sure that in 10 or 15 years you pay back, because there will be a cost of rehabilitation will increase. So you have 15 to 20 years of economic life. Okay, although the physical life of these some of these structures, civil works, mechanical works might be larger, but basically the economic life is considered 15 to 20 years. And the cost of the project is needs to be provided, and the cost includes the civil cost and the electromechanical cost and the other cost and the operation maintenance cost. And for in the case of Nepal, what they have done, the Energy Promotion Center, which promotes micro hydro, solar, wind energy in rural areas, uh, they have a subsidy policy. Depending on the location, depending on the socioeconomic condition of the village, they also provide subsidy. So the cost is actually, from an economic perspective, I mean, you have to look at the whole cost. But from a financial perspective, if there is subsidy provided, then the cost is reduced. But you also have a ceiling. You know, they don't want to fund projects which are too expensive, and so and they also want to make sure that the net present value is positive with a reasonable discount rate. Okay, here they put four, and I think this is depend. And Mr. Bart must have covered the sensitivity and the rationale and the significance of the discount rate. Because if you increase the discount rate, then especially for hydro projects, it will be a problem, because the benefits in the future is discounted. The present value of the future benefits will be small. So basically, we have, again, I think I showed you this during my earlier lecture. So basically, we look at what will be the source of investment. Is it a bank loan? What is the subsidy? What is the equity share? And I think this one, all these models have been covered by Mr. Bart. What will be the discount factor to be used? What is the breakdown? What is the cost of civil works, the electromechanical cost, and other things? What is the annual operating cost? These needs to be decided. And based on that, you basically find the net present value with and without the probable. You first look at the initial load, then finally you say, okay, after 3 years, there will be a business load. Then you basically get the cost per kilowatt and how much subsidy you will get per household, what is the cash flow. This is all being done, okay? And as I mentioned, you should, although I'm talking about the financial analysis of mini hydro projects, all the theoretical aspects and the process for these analysis was covered by Mr. Bart in his lectures FS01 to FS05, and I think he'll be doing more. So the materials presented and discussed in this lecture are only to support the financial analysis of mini hydro projects covered in the above lectures, okay? And with that, I want to now just do a small polling and to see let me look at this. Okay, okay. So I will just launch a poll, like, okay, now in your opinion, what do you think is the major cost of most hydropower projects? Is it the civil works? Is it the electromechanical components or other? And second question is, what is the major financial issue of hydropower projects? Is it high capital cost? Is it high operation and maintenance cost? Yeah. So let me give you 2 or 3 minutes to get your feedback. Okay, let me just give you some more time. Okay, so about half of you, 13 out of 21 of you have answered these questions, which are, thank you for that. I'll just end it now and I'll share the results with you. Okay, uh, there is about half of you have said civil works, half of you have said electromechanical, and one of you out of 13 has said it is other. Uh, in this one, basically, normally hydro projects, especially large hydros, have higher cost for civil works compared to the other components. But for micro and mini, sometimes the electromechanical cost can also be, if not as high as civil works, but similar costs. So in a way, for mini and micro, sometimes the if you look at my previous notes also, one example I gave was, I think electromechanical component also had a good cost. But civil works is normally the higher cost, but anyway, that's fine. And what is the major financial issue of hydro projects? 10 of you, 10 out of 13 have said high capital cost, and three of you said high operation maintenance cost. And normally, I mean, the hydropower projects have high capital cost, no upfront capital cost. Investment cost is high. Operation cost is only 1 or 2, 3% of the thing. So normally, the capital cost is the the main barrier, no, because you have to bring in a lot of costs compared to other type of like thermal projects have low capital but high operating cost. But hydro is this one. But anyway, thank you so much. I think this was quite useful, and I will just now go for one more question. Uh, like this is, I mean, of course, I should have, maybe this is not the right time to do this, but anyway, I'll do this. What incentives do you think should we provide to mini hydro projects to make it financially viable? Okay, as uh, you must have heard, sometimes the hydro projects have, especially in the rural areas, they are and quite expensive, no? Because the economy of scale is not there in developing countries. The construction may be expensive, the capital may be expensive, and other things. So, what do you think should be we should provide? What type of incentive should we provide? I gave, should it be subsidy, cash subsidy? Should it be soft concessional loans? Should it be tax incentives, or is there anything else we could? Okay, I'm getting some interesting feedbacks. Okay. Uh, yeah, 14 out of 21 of you have already voted. So I will just end it. Okay, I will now share with you the results. Okay. Uh, now, 4 out of 21 have said cash subsidy should be provided. Soft concessional loans, 7 out of 21, 50% of you said that. Tax incentives, 21% of you said we should provide. And in a way, I think all three are equally relevant. And so, I mean, if you have soft loans, then it will make the project financially viable because the cost of capital will be less. The debt servicing will, the cost will not be so high. Also, subsidies are provided, and even in, I think, in energy access programs in Africa, in Asia, there are certain criteria used to provide subsidies, and also tax incentives are also important thing, and especially for large hydros, tax incentive, because you may have certain uh, uh, taxations that rebates are given. So I think these are all important, but one thing is, but these factors will change your financial model. Okay, so it is important to know upfront. So it should be a national policy that has to be decided. Okay, and this will affect the financial model. So we have to be careful. Thank you. And with that, I will now, let me just, okay, yeah. Uh, I will now show you three formats, okay, to, uh, to help you understand. And this is, I have provided these references to you in the course lecture materials that was shared by Mr. Bhatt earlier in the morning. So please have a look at it. But let me just go here and let me just see. Okay. Okay. So the first format is the, this is the format used in my country. Like when you are doing a project cost, because you need the, for the financial analysis, you need the cost breakdown, the cash flow, the cost breakdown. Okay. So basically, sorry, the unit use here is rupees that we use, but you can use the, I mean, this could, you should, it should be changed to Mozambique currency or euro or dollar. And basically, these are the different items, the mechanical works, electrical works, civil works. This is the summary of the total cost, okay? And huller, grinder, expeller, other end use, tools, spare parts, trading. These are the categories. And normally, you may, I think in Mozambique also, you may have certain value-added taxes that you need to add to it. So we need to make sure we add that. And normally, depending on the level of detail we have, we also add the contingency of 10%. So this is the project cost, initial cost. And I just want to walk. Now, when you calculate the civil works, okay, so you have to do a rate analysis, okay? So by, sorry, I made a mistake. Okay. You have to do a rate analysis. So you should know the rate, okay? So basically, you know the quantity, and normally this quantity of, again, this is a sum, I mean, it's the details of the civil works, the concrete, the steel, and different materials that goes into it is also is given here, but this is just the summary. And but I just wanted to share this format to you, because if you are preparing the details, let me just go here. Yeah, detailed cost estimate is here, okay? For headworks, intake, wear, and protection, so you first need to fix some amount for site clearance. What is the cubic meter of excavation, and what is the rate of excavation you put and you get the value? How much of cubic meter of dry stone machinery? How much of gabion work? You have to get all the quantities. stone masonry, concrete work, reinforced steel, trash rack. So these could be different items, but these are the major items for to calculate the headworks cost. Okay, and the summary was given earlier. Similarly, for gravel trap, these are the description of work. This is the unit of thing. Then you need to get the rate. So when you are doing a cost estimation, a feasibility study level design or a study, you have to get the local rates. Okay, how much does 1 cubic meter of excavation cost? In is it $2, $1.5, $3? That rate, and normally government agencies also have contractors have these rates. So you have to do some survey in the market to get these rates. Okay, so these are sluice gates are they you go to once you get the size of the sluice gates, you can go to the local workshop and try to get the rates. Similarly for headrest canal, okay, these are the items you have to calculate the quantities based on your design, then you get the cost. Similarly, silting basins, forebay, anchor block items, okay, support pier. So these are the items that you need to get. Then for powerhouse, okay, building. So you have to get the design first, the simple design, then the quantity for each item, then based on the rate, you get the total cost. So machine foundation, trail race canal, these are different components of the civil works. Similarly, for mechanical components, you get the turbine cost. Okay, this now you have to go to a supplier and get a quotation for your rated discharge, rated capacity. What would be the cost? And you can get it. You can get a quotation estimate from the suppliers, from the turbine manufacturers regarding penstock, transmission line, these rates of steel pipes, what type of pipes you get, how much, depending on the thickness, depending on the diameter, you have to get the rate. So this is an important part of any cost estimation, and all the items are given here. So this will be very useful to compare with the practice in Mozambique. So please have a look at this sheets, and then you can get a full cost. You can get the full cost of the project. Okay, so this is the format that is used to generate the project cost. Okay, do you have any questions on this? Sorry, I'm just is it clear on the cost estimation for this, how the cost estimation is done? Anyone? If anyone has any question, please ask. Otherwise, I will move to the next format. Okay, looks like there are no questions either. I'm very clear, or maybe I'm not clear. You know, sometimes, but hopefully I will. I hope I was clear. But let me just go to an. Okay, I'm just going to the now the second the format. This one I think I showed you earlier, but this is the format. I want to walk you through. This is the format for to get the loads. Okay, you remember I showed you this. Okay, I showed you this diagram. Now, using this template, you can basically, if you enter, this is just an example. You can see my screen, right? Carlos, you can see my screen, right?
We can see it.
Yeah, okay, thank you. And in this screen, in the blue thing, I will just like, I will just walk, I just wanted to walk you through, explain to you the, sorry, what happened? Okay, so I mean, you put the basically, I mean, you put the kilowatt. Let's say it's 500, like it's 500 kilowatt, let's say, and then you put the name, project name here, village one, and how many beneficiaries, what is the plant operating day. I mean, this explanation is all there. And now you basically, you sort of give a tariff, no? Like, I mean, of course, you have to, for domestic purpose, what is the rate that you use, and this can be, you should, this is in Nepali currency right now, but you can change it to your Mozambique currency, and what type of loads are there, what are the operating hours, and what is the, after 3 years, what is the type of uh, business that you expect to get, and from which hours to which hour, what will be the load, how much of kilowatt. So these are certain estimates you get, and then you also put different end users. Okay, let's say agro processing, from which hours to which hour, bakery, sawmill, herbs processing, and different thing. Then based on that, you basically get all these dark ones are already calculated based on this blue information. Then finally, you get the load duration. Okay, this is the duration curve, and based on your, because I put 500, the blue one did not come here. I think it's less. I just put it 100, just to like give an idea. I think we should get the, anyway, this one, it should have come, but anyway. So this is the different load, and how it is done is calculated. So this is a format that is done, practiced for micro hydro, mini hydro feasibility studies in Nepal. So I just wanted to show you this. And the other thing I wanted to show you was the project costing and financial analysis part. Okay, now over here, one thing okay, over here in this one, there are different subsidy policy in Nepal. Okay, if you are, I mean, depending, because this was for remote areas. Okay, micro hydro for remote areas. If you are from a far away distance, then the subsidy per kilowatt was more. If you are near, because the cost of equipment, the cost of materials will be cheaper if you are near from major towns or cities. But if your village is very far, then you have a subsidy per kilowatt. So they have, basically what we have is a cash subsidy that is provided to the project developers. Okay, and then we use a discount rate, and then the blue one, okay, the investment cost is based on the cost estimation format I showed you. You basically get the cost of mechanical, electrical, civil works, and other cost of things. Then the annual operating cost is based on the salary, what is the spare parts, what is the maintenance requirement, and other things. So this is the operating cost. This is the total summary cost. And based on that, we basically calculate the cash flow. And I think this one, I mean, how the net present value, how the cost per kilowatt, how the internal rate of return, return on investment, this one is calculated when you get the benefit and the cash flow. So, and this one is already covered by Mr. Bhatt, so I will not go into the detail. But one thing I would just like to mention is, how do you calculate the cost? How do you calculate the benefits for a mini hydro is important. Okay, so this is the Nepal case. And similarly, when I was doing some search in the internet, I found one. I mean, it's a little bit old one, but it could be somewhere near in Africa. I think this is where is this? This is in Madagascar, okay? And this is an Excel tool for financial analysis of micro hydro project. It's 10 years old, okay? But I think it's okay. It's GDZ. So over here, he has given a template. I mean, there are other templates that can be used, but he has given a template which is developed by a GDZ project long time back. And of course, you could do that. And basically, what they have done here is you have different sheets, okay? The input data, the qualitative questionnaire, costs, revenues, gross cash flow, financing, net cash flow, general overview, sensitivity, subsidy of ADER is the Rural Electrification Agency in Madagascar. So just an example. This is a random example I wanted to give you, and I think what it says here is, I mean, you have to in the input data you fill in manually. So it depends on the project, and the qualitative questionnaire, the second unit also is done manually, and the cost the cost table is some manual and some automatic. After that, all the other inputs are automatic. Automatic means there is always a formula is given there. Okay, so in the input data, I just wanted to show you. Okay, basically the name of the project, the installed capacity, projected production of electricity per year, how much a kilowatt per year available for. So you see there is a less energy sold as produced. This is production losses. A captive electricity is given. The installation blah blah is here, and then it gives you it gives an economic life of not exceeding 20 years, has been declared, and then you have the cost of the civil engineering, electrical, pen stock, access road, and other construction costs, and everything is given here. Okay, so the lifetime, because then you have to you may need to replace it if you uh, 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 if the life if the if the lifespan of that particular item is less than the project planning horizon. Okay. Similarly, I mean, okay, these are some qualitative questions they have to follow, and then after that, all of these the costs, there are some automatic. All after that, all the revenue stream, everything is given is an automatic thing. So basically, in the input part, you have the thing. So you have to put the discount rate is important. So how many years a period under consideration? Is it for I mean 20? So it's basically the model considers a project period of 20 years. This cell, so you can make it 20 years, I think. And then you also have a currency exchange, euro to the local currency factor is given here. So these are, I think, the reason I wanted to share with you all this was it gives you an idea of the type of inputs you need for the uh, for the financial analysis. Okay, so okay, yeah, I think basically I wanted to these were the three uh, formats I wanted to share with you, and if you have any questions, I'll be very happy to take it now. Hello, is there any questions on? Basically, on the financial analysis, the formats and or on other aspects. Yes, Carlos, you were saying something? I
No,
cannot.
no, 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 no. I'm just waiting to hear some questions from the participants.
Okay.
Hello.
Yes, please.
Yes. About the previous question when you gave us asking about the most costly components, civil works and electromechanical components.
Yes.
I was 100% sure that civil works were the most costly components, and uh, it was very, yeah, you surprised me when you say that there is some project that have electromechanical components most costly compared with the civil works. It was very interesting when if you could show some examples, some projects that have electromechanical components most costly compared with the civil works. I don't know if it,
Yeah.
yeah, if it's possible.
Thank you. Yeah, thank you. Actually, you are right. I did not really mean to say that electromechanical were more expensive than civil, but sometimes I just show you one example. Like, okay, I had, if you remember, uh, this is like I just showed. Let me share this one. This was actually, sorry, okay, just a moment. Just a moment, okay. Just give me a minute. Uh, just a minute, okay. Sorry, I'm just trying to show you something that I. Okay. Yeah. Can you see my screen? Yeah. Uh, Basically, you see, there were uh, um, in a when I in my lecture 4, actually there were. I mean, I showed you some examples of small projects. Okay, and like over here, for example, this is one project which had a 6.2 megawatt. 66% was civil works, and only electromechanical and hydromechanical was around 15%. Okay, and over here, the second project here has 53 civil works and 38 and for around 42 hydromechanical. There was one 3.2 megawatt project. This project, okay, it's a, I mean, it will be very, you are right. Okay? This project, for example, uh, this project in Nepal, it's a, like I said, it totally depends on various factors. This project had only 30% civil works cost, and electromechanical and hydromechanical, they had total 44%. Okay, so this is what I meant. But normally, you are very right. that in most of the majority of the projects, civil works is the maximum cost. But over here, just a small, there are some very projects of that type of like over here, for example, you see civil works was 53%, this particular project in Nepal, 5 megawatt. Okay, so it's a this one had 66% was civil works, and this was by, it also depend on the developer or something. This one by a private company had only 30% civil works, then 23 and 21, 44% electromechanical and hydromechanical. So I included lump that too. So this is a very rare case, and this is one project. This was part of the. This is one project. Okay, you see, this is one project, less than 1 megawatt, recent project, and over here civil construction cost is 29%. Okay, and they have 25% of hydromechanical. Okay, and they put, depends on how they put. So they put the powerhouse equipment 16 here. So if you add 16 plus 25, so this is 41%. So this is, if you add the hydromechanical and the when you say powerhouse equipment, I assume that this is the turbines and generator. This is more than the civil works. So, but you are right. In general, civil work has the normally, if somebody asks me what is the largest cost, I would also say civil works. But there are, for small projects, for large projects, in most of these projects, it's civil works for sure. Yeah, thank you. You have a very, your question was very valid, and your observation is also very valid. Thank you.
Okay, thank you. And based on this, is it possible to have the relationship between the cost of the components and the type maybe of the dam, software, or the turbines? Is it possible to have the relationship of this?
Yeah, in some ways you can see, like normally when you are doing a pre-feasibility desk study, they use that, no? Like I think in my previous lecture, in my just a moment. Okay, here I will show you. Like, okay, this is just if you remember, you can see here, right? So project cost summary of mini hydro. This is the presentation I made 1 or 2 months ago. So you see, this is electromechanical cost is around 350 to 400 per kilowatt, and per ton. Civil works based on blah blah. So basically, per kilowatt cost of electromechanical is around 400 USD based on some recent projects. Yes. So you have these thumb rules. Yes. Yes, Mr. Sambo. Did I answer your question?
Yes. Thank you.
Thank you.
Yeah,
Yeah.
it was clear. Yeah.
Thank you so much. Yeah, any more questions? Was I clear today? I mean, I was trying to give you an idea. I mean, like, since we're coming, it's not, I did not want to go into the technical details of design and feasibility technical studies, but today I wanted to give you an impression of any project hydropower development is not just playing with the hydraulic design or electrical component design. You have to make sure that the financial package is correct. You have to make sure the social, environmental safeguards are Otherwise, you will get a lot of opposition to hydropower projects, you know. So these are two very important parts of a feasibility study and the evaluation of projects. This was the intention of the discussion and the lecture today.